Hello everyone, hope you are doing good and welcome back to again for the new video. In this session, we are going to learn how to do generation mean analysis in R Studio. So many of my YouTube followers asked me to do a separate video on generation mean analysis in R Studio. So generation mean analysis is used mostly in plant breeding to estimate the genetic effect, the gene effect, additive effect, dominance effect, epistatus effect, and other interaction effects. So this is quite cumbersome calculations. It has a lengthy formulas and all those stuff, but it's very easy. So it has a different generation population, like parental generation, F1 generation, F2 generation, backcross 1 generation, and backcross 2 generation. So after when they asked me to do a video on generation mean analysis in RStudio, I did search in Google for any packages. So luckily I found one package called gmaR. It's developed by Wahindamola James, and this is the GitHub address of this developer, and he has done a very nice job developing a RStudio package for generation mean analysis. The functionalities include A, B, C, D scaling test, joint scaling test, 6 parameter model, and heritability and heterosis. So I will attach this link in the comment box so that you can refer to this, and you can also explore his GitHub profile if you want. And so going back to the studio, so first we need to arrange the phenotypic file. So let me show the phenotypic file. So this is the phenotypic file. So I'm taking a trait called plant height, and it's in the centimeters. So this is all parental one. So all the parental plants, the P1 plants are represented here, the P2 here, and the F1 plants here, and the F2 plants here, the backcross one, backcross two. So data is index type, not a raw type. It's an index type. So so you need to be very careful. This should be capital letters, and it should be in the same letters I have mentioned here. The P1 should be capital P1, P2 should be capital P2, F1 should be capital F1, F2 should be capital F2, and BC1 should be capital BC1, and BC2 should be capital BC2. And this should be the same in your data, in your phenotypic file. And you can name as whatever you want, the column name, genotype, or just gen, and the plant type. So this is saved in working directory here. So I'm going to set my working directory. This is set working directory, and import my file, the phenotypic file, from Excel browse plant type, and keep this as a numeric, and this is a character import. So first to install gmR package, so this is the code. I will share all these codes in the comment box so that it will be useful for you. And I have already installed this package in my RStudio, so I'm not going to do this stuff. So you just need to take uh, uh, run this code. Then you need to library the gmR package and dplware package. So dplware package usually there in RStudio. So if you don't have dplware package, then install dplware package and library both gmR and dplware package. So after doing library, and this is the data, the plant type and generations, and I already done the setting working directory. So you can get he has given a code. The developer has a given code to get the summary data set. So so this is the data set. So my data set name is PhD. So this the dataset name is PHT, and if you put a dollar sign, you will select the column name. This is the genotype, and I'm doing the same here. This is the trait, the plant trait, and you get the summary, the same code, gmR get summary, run it. So you will get the mean variance, weighted variance, all those stuffs, and the number of plants for each uh, generation. And if you want to do the scale test, the code is simple, gmR scale test. Same, the PHT dataset, select the column, genotype column, and here the select the plant type column and run it. So you will get the scale test, ABCD test, and you will get the significant values and all the parameters. And if you want to do the joint scale test, the same different, quite different formula, quite different code. The joint scale test, select the genotypic column and the trait column, the same thing, and control enter. So if you do the control enter, you will get the joint scale test. You will get all this MDH effects, additive effects, dominance effects, and all those stuffs, mean and all those stuffs, and the chi-square values and the significance and all those stuffs. And the next is if you want to do the perfect fit test, the gmR perfect fit test, the same thing, select the genotype column and the trait column, control enter, and you'll get all MBHIJL. That's what you get in generation mean analysis, and the chi-square values and all the chi-square values and everything you need, significance values and everything. And if you want to calculate any genetic parameters like atrocities, genetic variance, all those stuff, so this is the simple code for this, and just run it. So you'll get all the genetic parameters, atrocities, PCV, GCV, and all those stuff. So this is very useful package for generation mean analysis, having scale test, joint scale test, and perfect fit test. And yeah, I think this video is very useful for you. Take care. Bye bye.